So we're going to talk in this class emphasizing some retrosynthesis, which is one of the most basic and the prominent important in drug delivery and every facet, one of the most basic facet in organic synthesis. That is retrosynthesis. It has a common terms or a circular meaning known as backward reaction. So it has a common terminology. We refer to it as backward reaction. That is, how can we go back to the genesis of a reaction? That is, how can we trace the possible pattern with which we got a product? You know, in chemistry, we have two phases of a reaction. It's all called the reactant and the product. That is, to get a product, you must have a reacting molecules forming together, maybe reactant A and reactant B, to give us a product known as C. So that is now a question might be can be suggested within scientists that from this C, how can we trace back to the genesis of the reacting molecules that give us this C? At least for example now, we have lineage, so we have pattern from every families. So for example, you recognize someone from a particular family. So now, then the villagers might think that what is the pattern, that is from which generations or from which lineage is this specific person from. For example now, we have elements A and B reacting together to give us what? C. So we know that this is the reacting particles A and B, which are the reacting particles to give us what? C. So now, the question here, according to retrosynthesis, it is not as straightforward as it is what the vice versa of this. That is, we have the reactant A and B to give us C. So retrosynthesis, this is just a forward reaction. It is a forward reaction. But retrosynthesis, nothing concern, and it is not a forward reaction, but it's the vice versa of this equation. For example, we have this is the reactant and this is the product side. So now for the so retrosynthesis deals with C, that is, which is a bigger molecule. These are, let's for example, these are monomers. If you are dealing with polymer, we can say these are monomers, the reacting particles A and B to give us C. Let's assume this is a macromolecule. For example, when we talk about polymers, it is a combination of two or more monomers to form a bigger molecules. This one can be in thousands of thousands to form a more bigger and more complex molecules. So now, that is, if you have gotten our bigger complex molecules, that is, how can we get back the monomers, that is, the reacting particles? For example, you know that A and B gave us C. So now, if a question arises, so you as a chemist, a question was suggested to you. I have a compound C, but I don't know, I was not there when the compound was formed. But how can I get the starting material if I want to reciprocate the same by forming this same compound? If I am in my absence, a group of scientists gave a compound C. For example, there's what we call dexamethasone. It was produced in the lab. So, but you are not there. You don't know the starting material. You don't know the reacting particles that gave us that compound. But as a chemist, there's a way we can know the starting material through the help of what? Retrosynthesis. That is, retrosynthesis deals with what? A target molecule to find the what? Precursors. That is, we have a specific molecule now. For example, we have C, which is our target molecule. That is, how can we get the precursor, that is the compound, the element that combine together to give us C? So this is the backwardness here. We have A and B. So as you can vividly see that we got C from the reacting when C is being broken down. So in this part, we'll be talking about cleavage. You will have a deep understanding on what we mean, what we meant by homolytic cleavage and heterolytic cleavage. That is, if we should break C down into smaller to the possible smaller units, we should be able to get the reacting particles. So we can see we have A plus B that gave us what? C. So now we have C here to know which is the target molecules. The molecules, we want to know the precursor. That is, when we talk about precursor, reacting particles that give us the target molecule. So now we have C, which is the target molecule, so we are told to find the precursor. So now in the base of in our basic chemistry understanding, we have what called reaction mechanism. Every reaction has their mechanism, that is the pathway with which they occur. So for example, you have C now, that is how can we get the reacting particles, that is the smaller particles. This is a, for example, this is a, let's assume this is a macromolecules, that is a more complex structure, which is C. So now if we break C down into a smaller unit, we should be able to get what? The reacting what? Particles. So now C is being broken down. We have A and B as the what? Reacting particles. So now we will definitely make use of our basic understanding in chemistry. We have different kinds of reagents. How some reagents function as a oxidizing agent, and how some reagents function as a what? As a reducing agent. So we also talk about retrosynthesis terminologies, that is the terminologies involved in retrosynthesis.